All right, so lecture 3.2. So we're taking a look at polynomial functions. All right, so polynomial, those are what we've seen before. But for polynomial functions, there's one thing we like to look at is kind of describing the graph, and also one main thing is the end behavior of our graphs. And what are we talking about when we're talking about the end behavior? Well, kind of what it says, end. We just want to look at the two ends of our graph, but we're going to describe them in a certain way. Okay, so what we tend to focus on is the fact there are two options. One, and you'll see it right here, is we want to know as our x values slowly start heading towards negative infinity, what's happening to our y values? Are they also heading downwards towards negative infinity, or are they heading upwards towards positive infinity? Well, looking at our graph here, as my x values start getting smaller and smaller and smaller, heading towards negative infinity, what happens to my y values? Well, they're starting to go up, 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 up to positive infinity. So how we'd write this is f of x, remember, these are our y values. As f of x heads towards positive infinity, my x values are heading towards negative infinity. Okay, let's look at the other option. So always we're just looking at as our x gets big and as our x gets small. Those are what we're focusing on. Okay, so notice that's why these two values are left here. So as our x values get bigger and bigger and bigger, what's happening to our y values? Well, notice our y values are starting to head down into negative infinity. Okay, so as our x values are getting larger and larger, our y values are actually getting smaller and smaller. So they're heading towards negative infinity. Okay, and how we read this is as f of x approaches, okay, we say approaches positive infinity as x approaches negative infinity. And how we read this one is f of x approaches negative infinity as x approaches positive infinity. All right, and now there are four different sort of options we have. Let me zoom out a bit on this. Actually, let me just adjust my camera. All right, so we have four different options for the end behavior of our polynomials. And this is if we're looking, remember, at a polynomial like ax to some power n, plus, 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 and on until we end up with some coefficient, let's just say b. Okay, so any polynomial like x squared plus 2x plus 3, that would be an example of a polynomial. So we're going to look at the degree of the polynomial. For example, x squared, the degree would be 2, positive. We're going to look at whether the degree is even or odd. And then we're going to look at the leading coefficient of our polynomial. For example, negative 2. That would be a negative leading coefficient. We could also have positive 2. All right, so those are the main two things we're going to look at to help us decide the end behavior of our graph. And then I'll give you an example kind of what those end behaviors look like and a function that we use. So first option, we can have an even degree polynomial, like 2, and then a leading coefficient that is positive. So what happens here is as f of x approaches positive infinity, as our x values approach negative infinity. And then f of x approaches positive infinity again as x approaches positive infinity. So an example of this is y equals x squared. The parabola. So notice, as if I was to just put my graph in here, as my x values get smaller and smaller, my y values are getting bigger and bigger. And as my x values get bigger and bigger, my y values still get bigger and bigger. Okay, so I'm going to go ahead and put the examples alongside the columns here. And then we'll fill in this chart, and finally we'll fill in the end behavior. So let me go ahead and put in our examples first. You know what? Let's see. I think I want to make the graph part black so you can kind of distinguish the axis from the actual graph. Let me white that out real quick. Come here. Okay. Okay, the other example. Third example. And fourth example. Okay, so here we go. These are the examples we're going to look at. All right. So notice the ends on all of these change. For this one, both of the ends are pointing upwards. This graph, both the ends are pointing downwards. This one, the left is going down and the right is up. And this example, the left is up and the right is down. Okay, so for this one right here, this is when we're looking at a graph where the degree is also an even, like our example, but the leading coefficient is a negative number. So what happens here? Well, we can look at our graph to kind of get an example. As our x values are getting smaller and smaller, our y values also get smaller and smaller. Okay, so they head towards negative infinity. Let's look at this other side. As our x values are getting larger and larger, our y values are getting smaller and smaller. So f of x heads towards negative infinity as x approaches positive infinity. Go ahead and see if you can fill out the last two parts here using the examples. All right, so hopefully you've decided to try that by yourself. So here we go. This is when we're looking at a degree that is odd, but we have a positive coefficient. So what happens here is as our x values approach negative infinity, our y values also approach negative infinity. So as f of x approaches negative infinity, as x approaches negative infinity. Now, looking at the other side, as our x values are approaching positive infinity, our y values are also approaching positive infinity. Okay, and the last option, once again, is an odd exponent, or an odd degree, and our leading coefficient is negative. So this time, as our x values are approaching negative infinity, our y values are actually going upwards, approaching positive infinity. And then, looking as our x values are approaching positive infinity, our y values are heading down. They're heading down towards negative infinity. Okay, and there we go. These are the end behaviors of polynomials, the examples for them, how to describe their end behavior using mathematical notation, and then the ways that you can visually identify the behavior or the polynomial that you have. Okay, let's go ahead and make use of this. All right, so first example. Let me pull this in. All right. Use math symbols to describe the end behavior of the polynomial. Well, that's just what we created now. So let's see. Remember, we're looking at the leading one, so we have a degree 4. So the degree is 4 even or odd? 4 is even. And the coefficient is negative. So we're going to go ahead. You can either think of the example, which is y equals negative x to the 4th power, or you can just go back and look at our chart. So we had even and negative, which means this is the end behavior we're looking at. Okay, so the end behavior is p of x. Okay, remember we're using p of x, not f of x. P of x approaches negative infinity as x approaches negative infinity. And then p of x approaches negative infinity again, but as x approaches positive infinity. And if you want to go ahead and figure out what these graphs look like, you can plug them into your calculator and see if the end behaviors do indeed match what we've described. All right, so let's take a look at the next one. Go ahead and try plug that in, or go ahead and try see what the degree is, the coefficient, and then how to describe the end behavior. Take a second and try to do that by yourself. All right, so the degree is 7, so that's odd. And the coefficient is positive. So for that one, let's look back at our charts. We're looking at odd, positive. That is going to be right here. That's how we'll describe it mathematically. And this is an example visually for us. Okay, so describing it mathematically, remember we're using p of x as our polynomial name, not f of x. Be careful. So p of x approaches negative infinity as x approaches negative infinity. And then p of x approaches positive infinity as x approaches positive infinity as well. And once again, you could plug those into your calculator or look on Wolfram Alpha or maybe Desmos. Those are two different ways that you can graph online. I'll go ahead and write those names there. Wolfram Alpha.com is a great site to go and plug things in, or Desmos.com. Great, two great sites to plug things in and try to see your graphing. Wolfram can even help you sometimes with solving problems. All right, so let's take a look at what the zeros are. So zeros of a polynomial are actually just the x-intercepts. So the plan is you just factor your polynomial and pull out your zeros, and those are what you call your zeros. So p of x, can we factor this? Yes, we can. That's going to equal x minus 2, x plus 1. So my zeros are x equals 2 and x equals negative 1. Okay, go ahead and try pull the zeros off for part B. All right, so the zeros for B, pulling them off, it's going to be x equals 1, x equals negative 5, x equals 6, and x equals negative 3. And if you might be stumped as to how I'm getting these, remember what we do is we set each factor to 0 and solve for those factors. All right. Intermediate value theorem. Okay, let me just shift this. So graphing a polynomial. So when we're graphing a polynomial, the things we want to look for are the end behavior. Ooh, a bird just tapped on the window. Interesting. Okay. Distractions. Okay, he was trying to get in this room. Okay, so we have the end behavior of a polynomial that we look for. Then we check to find the zeros. That's where our polynomial hits through the intercepts. Also, we check for our y-intercept. And then if we need any test points near our zeros, we can go ahead and find those. All right. So let's see, end behavior. Can I find the end behavior? I can, because I have it in this nice form where everything's multiplied out. So my degree is my degree is odd, and my coefficient is negative, which means my end behavior is going to be, let's see, that was odd, negative, yes? Okay, so f of x, or p of x approaches negative infinity as x approaches negative infinity. Sorry, I said that wrong. P of x approaches positive infinity as x approaches negative infinity. And then the other one we have is approaching negative infinity as x approaches positive infinity. So another way to think about that is this is what the end signs of your graph should look like. The left should be pointing up and the right should be pointing down. I'm going to go ahead and just start my graph here real quick. All right, let's go ahead and find the zeros first, okay? Because I don't really know where my graph is going just yet, so I'm going to find the zeros. So to find the zeros, I need to factor this baby. Okay, let's see what's in common here. They all got an x, but when I factor out an x, I'm going to end up with an x squared term. So to make it look nice, I'll factor out a negative x. So I'm left with 3x squared plus x minus 1. All right, so I can factor this polynomial here. So factoring that, that's going to be, let's see, 3x minus 1 and x plus 1. So then my zeros, I have 3, because there are 3 terms. Or sorry, three factors, excuse me. So my zeros are going to be x equals 0, that's from here. x equals 1 over 3. Got that from this one. Remember, we'd set it to 0 to solve that. And x equals 1. Okay, I'm going to go ahead and now notice the very big, huge key word in this entire problem is we're sketching the graph. Okay, it's not an exact graph. We'll get on how to do the exact ones later. But this is just a sketch. Okay, so all I'm going to do is indicate the main points, which, as we said before, are end behavior and the zeros and the intercepts. At this moment in time, that is all we're doing when we're sketching the graph. Okay, so I'm going to go ahead and point out my zeros. That's at 0. Then I have one at -1 and another 0 at a third. Okay, now I have to figure out what the behavior of my graph is going to look like. How am I going to sketch it in? Well, luckily, I know what the end behavior looks like. I know that on this side of the graph, it should be going upwards. But I also know it has to hit that point right there. So from this point, it's going to head up. I know that because of the end behavior of my graph. But then the question is it supposed to go down, then up? Or is it supposed to go back up and then down? I don't know if it's supposed to be in the top or the bottom. Well, to check that, let's go ahead and find a test point. Because I don't know if it should be above or below. Okay, I'll pick a test point in between these 2 points because this is the section right here that I don't know if it should be above or below. Okay, so I'm just going to go ahead and draw in my 2 options. I have this option, or I have this option. Okay. Now, when I plug in my test point, I'm actually just going to care about the sign. Because anything, if I plug in my value and I find out that I have a negative answer for my y, I know it's going to be this option. Because these are the negative y values. Anything below here is a negative y value. If I plug in my x value and I find out I have a positive y value, I know it's going to be the option up here for my positive y values. Okay, so let's go ahead. So I'll pick an x value of in between -1 and 0 would be a half, -half. So I'm just going to check the sign. -half times -x, that's going to be positive, times, plugging it in here, that's going to be a -3 something minus 1. That's going to be a negative. And then plugging it in here, that's going to be a positive. So my final answer is going to be a negative, which means the option I choose will be the negative option. So that's what the test point is for. Okay, and I don't actually know if it just dips this low or if it dips even lower. I don't know. Remember, we're just sketching, so don't worry. As long as you get the idea of if it's above or below this axis. So that's what the test point's for. Checking if it's above or below. All right, let's check this point in between here, 0 and a third. What is smaller than a third? A fourth. Okay. Plugging that in, so same thing, we're trying to figure out if we're going to go with the positive option or the negative option. Let's see, a fourth times that, that's going to be a negative. Plugging a fourth in here, that's going to also be a negative. Plugging a fourth in here, that's going to be positive. So multiplying this out, I end up with a positive, which means we're going to go with our positive option. Okay. All right, so one more option to do is we need to see if it goes up or down. So you might be thinking we have to do another test point, but we actually don't. How do I know we don't need to do another test point? Right here. I know. At the very end, my graph should be heading down, which means this is not the option we're going to use. We're going to go ahead with this. Okay? So that's why it's nice to be able to see your endpoints, because then you don't have to always do a bunch of test values. And there we go. So on these sides of our zeros, we were able to use the endpoint behavior to graph. And in between, where it was a little messy, we had to go ahead and pick a value and test if it was positive or negative to figure out if it was above the axis or below the axis. All right. Let's see, 2 more to go. Awesomeness. All right. So we're going to shape a graph near a 0. Okay. So same idea here, kind of what we did with our test points previously. So let's see. It's already factored for us. Oh, but notice we don't know what degree it is. Oh, we could kind of find that out. But for now, we're just going to say we don't know what degree it is, and we don't know what the end behavior of the graph is going to be. So because of that, we're going to need to use test points all the way. Okay, what are my zeros? Well, notice these are doubles of each other. So at this moment in time, they just give us 1, 0. So x equals 1. And then these are all also a bunch of doubles. So we're going to use x equals -2. Okay, right there, those are our values. Oops. Okay. So 1 and -2. Here we go. Here's 1 and -2. Our zeros. So now we have to figure out how to graph this, or how to sketch this. Actually, remember, we're also just sketching. So I need to know, is my graph going to be heading up or down? Positive or negative? Well, once again, to check that, we're going to have to go ahead and use our test points. Remember, we're just looking at the sign. So what's smaller than -2? Let's go with -5. Plugging those into these signs, let's see, that's going to be -5 in here would be a negative. Also a negative if I plugged it in there. -5 plus 2 would be, again, a negative. And those are all the same, so that's all going to be negatives. All right, multiplying this out. Negative times negative is a positive. Positive times negative is a negative. Negative times a negative is a negative. And then negative times a negative is going to be negative. So there we go. End is negative. Which means the option we take is the negative. Whew, all right. Next section is between these 2 points. So we have 2 options. The positive or the negative. And I don't know what these look like. It could be going up higher or just a little bloop. I don't really know. But remember, we're just sketching. For now, we don't know how high or low they go. All right, so picking a point in between here, let's go with 0. If you can go with 0, go with 0. Go ahead and see if you can plug in those test points and see what the signs would end up being. All right, working with the test points, I'm going to go with, it gets negative, negative, and then the rest of them are all positive.